Hi, good morning or good afternoon, whatever you are based on. Welcome to another online tech talk in AWS. Today we're going to talk about time series analysis and forecasting, and in particular, we are going to talk about Amazon Forecast. Amazon Forecast is a service that was announced in the last reInvent last year, and today we are going to go through the advantages that we have with Amazon Forecast and how to work with it. We are going to have a demo and actually two demos, and we will go deep on the service to see how to use it for your analysis and the time series work that you do in your day-to-day. My name is Antonio Rodriguez. I'm solution architect in AWS. You can find my Twitter handle in the slide, and you can also contact me by email. I will leave you my details at the end of the presentation. In Amazon, we have the what we call the machine learning stack, which is composed basically by three layers. So the first layer is what we call the machine learning frameworks and infrastructure. In this layer, we basically have all the frameworks that are useful for working with deep learning applications. And whenever you are going to do advanced machine learning and you need to get full control on the environment that you're using, but you just don't want to be handling the infrastructure. So basically, you work with Amazon EC2 services and basically container services that we have in AWS as well. And we have images that are pre-built for machine learning with those frameworks and with the interfaces and libraries that you need. An example for TensorFlow, for MXNet, for PyTorch, and working with Gluon, Keras, and so on. The middle layer is what we call the machine learning services, where we have the star service in this layer, Amazon SageMaker. With Amazon SageMaker, you can build, train, and deploy machine learning models. It has a set of pre-built algorithms. It allows you to do things like hyperparameter optimization. It allows you to work with Jupyter notebooks and create endpoints for hosting your models and so on. It's like the platform where you can actually get rid of anything that has to do with infrastructure, installing software, patching, and these kind of things, and you just focus on your machine learning work as a data scientist. And the final layer, where we'll be working today, especially, is what we call the artificial intelligence services. And in this layer, we have services where the user wants to basically use REST APIs, and through those APIs interact with the services that in most of the cases are pre-trained for just answering to inferences on information. The example, with video or with images, you might want to detect objects, you might want to do classification, you might want to use it for text, you might want to use it for translations, for voice to text, text to voice, and so text to speech, speech to voice, and so on. And one of the services that we have in that layer that was announced in the last reInvent, as I said before, is Amazon Forecast. And Forecast is a service that is basically an abstraction of this layer for interacting through APIs with a service that allows you to use your data with algorithms that the service provides in a very simple way without requiring any machine learning experience and having advanced and accurate forecast capabilities. So moving on, when we talk about predicting and doing forecasting in general, we generally have two challenges. If we forecast too low, so let's say that in that curve that we have in the picture, we have an inventory or we have sales. If we go too low, we basically miss opportunity cost. We might have disappointed customers. Let's say that you don't have enough items in your warehouses for the demand that your users are having, and so on. If you are forecasting too high, then you are probably having higher costs that you were expecting originally, and then you will have an excess on inventory and things like that. So it's important to have an accurate forecast because it has a direct impact in the business that you might have. Some sample use cases where forecast is critical is product demand, of course, in retail and this kind of business, inventory planning, but also in workforce demand when you have to plan resources for a given task or a given project, and financial metrics. In example, when you have to do a forecast of sales or opportunities and so on. Those are just some of the use cases, but of course, forecasting can be extrapolated to many, many different applications and businesses in general. So Amazon Forecast is basically a way to have a service that has the more than 20 years of experience that we have in forecasting at Amazon. And when I say Amazon, I mean the whole Amazon corporation, including the retail part. In Amazon retail today, we have more than 2 million vendors and more than 2 billion products. And we have to do a forecasting for making sure that we have the inventory on time for delivering the goods to our users. And we do that with a series of machine learning and deep learning algorithms in particular. And we have to do that with a very good accuracy for making sure that the business is healthy. So that's basically the same know-how that we are exposing with Amazon Forecast to our users in AWS. So our customers through the console, through the API, through the SDK, through the CLI, can basically interact with this service for passing the time series data and getting back an accurate forecast on what is going to be the future of those KPIs or that we might be interested on. So it's based on that technology, and we say that no machine learning experience is required because that's the difference basically versus using a Amazon SageMaker approach, in example, where you actually have to work in your models and let's say work in your notebooks for actually coding what is exactly what you want to do with those algorithms and so on. In this case, the service does everything for you. You just have to choose some basic options and give some shape to your data, and it basically returns an accurate forecast. It packages a suite of algorithms that include some statistical methods that are very common for doing forecasting in general, but it also includes deep learning algorithms. And the deep learning algorithms improve the accuracy by up to 50% in the tests that we have done inside Amazon, at least. And that's especially important and it's especially impactful in terms of accuracy for datasets that has over 1,000 time series. So when you have data that is complex and you have hundreds of features and you have many time series combined and so on, that's where the real power of Amazon Forecast is seen, because it basically outperforms the traditional methods. So let's look a little bit about those traditional methods. So in typical traditional time series models like exponential smoothing or auto ARIMA and non-parametric time series models, Prophet, etc., we basically work with independent forecasts, which means that we have a single time series and we work on that. We have a strong structural assumptions, meaning that we assume that the data it has a given shape. We have a sessionality, and we assume that this sessionality is regular through all the data. And that's a well understood method that has more than 50 years of research. It's highly efficient in data. But unfortunately, it has some assumptions on the structure of the data that are not always real in our real life data, and we cannot also identify patterns across different time series at the same time. So we have to work in a scalar way. We have to work with a simple single time series at the time. So in example, if we have this graph here, we typically have a trend and a sessionality. So the trend in this case will be an increased trend, as you can see here. You can imagine a line here growing, and then we have the sessionality, which is like this wave that we have here in orange. The real world time series are often more complex. So it will look something like this, an example, where you probably have some other variables, other time series that are affecting the target variable. So in example, you might have fluctuations in price. You might have items that suddenly are out of stock, if we are talking about an inventory, in example. You might have promotions in your business. And all of these things will cause spikes, will cause zeros in your data, and will cause variations at the end in the way that we have the data in general. So at the end, traditional methods struggle with those real-world series because, first of all, they don't consider metadata. They can handle proper sessionality at the end because it's not able to think beyond or process beyond the single time series that we are passing. It doesn't consider related variables. An example, if we have a price, we have holidays, we have a Black Friday, things like that that can impact our forecast on a given moment. That's not included. That's not considered. Any promotion that we have, any items, categories, or things like that are not considered at all. And the last thing is that if we have a new item, let's say that I'm working on a shoe factory and I have a new model of shoe, how can I forecast for that item if I don't have historical data for it? So with traditional methods, it's impossible that I can make an accurate forecast for a new item that I have or I want to launch. So that's where we can do better, and we can do better basically using deep learning. So by using deep learning, we have some algorithms, like in example, the autoregressive LSTM, which is also known as DeepAR, the SQF, the MQRNN, and in general, all of the algorithms that are using recurrent neural networks for working with the data. The good thing about it is that it can group sessionality, it can group behavior in the different variables and the different inputs that we have in our data. It has some weak structural assumptions, so we can actually make it more flexible for changes that we have in our data sets and for changes that we have in the patterns that we see in the data across the time. It can be at the end significantly more accurate than the traditional methods for big data sets. And the good thing is that we can incorporate that metadata. So, an example, I can have the categories of the item, I can have the price, and so on. It also supports cold start for new items. So, in example, if I have that new model of shoe that I was talking before, it's able to identify that it has some properties that are similar to other items that I have in my inventory. And based on the behavior of those items in the past, it can actually correlate and get to an idea of what will be, in example, the sales or the demand that I can have for that new item before I launch it. So that's a method that is being used modernly especially in the retail market and so on, and it's very important when analyzing time series. So the other thing is how do we work with those covariates? So as I said before, I can have a main category that is called fashion, and inside fashion I can have women, men, girls, boys, and so on. And then inside those I can have some subcategories, like in example, clothing, shoes, watches, and so on. So that's information that builds a hierarchy, so it can be a hierarchical category input at the end, where we can identify some patterns at the group level. So, an example, what is the behavior of the men's category in general in fashion, or what is the behavior of the clothing in general across categories, and so on. So at the end, using deep learning, we increase the accuracy, and we can have, as you see here, some examples. Those are examples that are documented in the paper that you see there in the URL. Basically, we have demonstrated how at Amazon we can actually use these methods for increased accuracy in different types of forecasts. In example, you can have forecasts like the two that you have at the bottom, where you have cold starts or you have promotion spikes, in example, and see how that impacts the target that you have at the end. And we can actually predict or anticipate to that accurately. So Amazon Forecast at the end is a service that helps you increase in the accuracy, as I said, up to 50% in the numbers that we have done, in the tests that we have done so far. And it's just a 1/10 of the cost, because it's a service where you basically pay per use. So you basically pay for the number of forecast calls that you are doing to the service, and for the data that you are actually uploading to the service for analysis and so on. Is basically automated machine learning for getting results quickly and accurate forecast. So that's the value that we have behind this service. The way it works is basically by using historical data. An example, any target KPI in time series that you want to analyze, let's say sales, inventory, pricing, and so on, and then all the related data that we can have to it. So, an example, holidays, weather, competitive promotions, and so on. We basically load this data, and the service allows us to inspect it. It identifies the features automatically, so it does the feature engineering for us. It allows us to select the algorithms from a list of predefined algorithms that it has, or it allows to do auto ML. So it basically allows the service to choose the best algorithms for us based on what is the best precision or accuracy that we have in our models. It also allows us to play with some hyperparameters if we want, and in Sol specific algorithms, it also allows to do automatic hyperparameter optimization. And then it trains the models, optimize those models, and then allows us to deploy it and host those models for making the forecast calls using API. So all of this is done by the service automatically. There are three different types of data sets in Amazon Forecast in general. So the first one is our target time series. Let's say, as I said before, we are working with predicting the demand that we have for given products, or predicting a financial KPI that we want to analyze, or we are predicting, let's say, an engineering KPI for a machine that works with some time series, or an IoT device, or something like that. That we have the related time series data. So, an example, web hits, if we are working with click streams in our website, or holidays, as I said, or the price of the items, or other KPIs in engineering that I might have, or other sensors in IoT, etc. So, any other time series that I can correlate the behavior with. And then the metadata. So, an example, if we have items, what is the category, what is the gender, what is the brand? In other domains, an example, in IoT, what's the location of those sensors, or what's the group of sensors, what's the vendor, and so on. So any metadata that we can have about our variable, about our time series, that can help us identify trends. And basically, we have different ways of working with the service. We will be seeing this in a minute, but basically, this is a look of the dashboard that we have in the AWS console for the services. This is the way to work with the service in a graphical way. So we just go through the process of uploading the data sets, or indicating basically where the data sets located in our Amazon S3 buckets. We train the predictors, and that's basically training models based on the algorithms that we want to choose, or choosing AutoML and so on. And when we have those models trained, we can actually generate forecasts. So we can look up for a specific period of time, and then see what's the variable looking like in the future. For training the models, we have a pre-configured algorithms that we call recipes, and we can choose from a set of statistical methods, and also deep learning methods. So, in example, you see here ARIMA, ETS, MPTS, Prophet, and we also have DeepAR Plus for working with deep learning, and we keep adding those algorithms with the time. You can also train custom deep learning models, and that's a feature that is coming now. And basically, to compare with the models, with the algorithms that you have already trained, and you can also work with the accuracy metrics easily, so that you can see which model is better than the others, and so on. So, some words about the algorithms that we have. Some of those are, as I said, the autoregressive integrated moving average, or ARIMA. The ARIMA is an statistical algorithm. It's very useful for data that can be mapped to a stationary time series. So it's very common. It's the star algorithm for years for forecasting. It's based on the package forecast of the comprehensive archive network, or the CRAN. And the way I think about ARIMA is that it works as a filter. So it basically separates the actual signal from the noise that we have in our data set. So that's basically the power that it has in general. Another algorithm is the exponential smoothing, or ETS, and is also an statistical algorithm. It's useful for a stationary time series, and it basically works by computing weighted averages. It's based on the ETS function of the package forecast of CRAN as well, and it's also very common, and it has been used in the last year, especially a lot. It's very simple to use, very straightforward as well. The other one is a non-parametric time series. Is useful when we have time series that are intermittent. In example, where we have sparse data, we have data that has many zeros or many blanks, and even when we have data that is bursty. In example, we have sudden peaks in the data and so on. It's very similar to ARIMA and ETS, but the difference is that it works in prediction ranges. So it allows to give an extra value for working with this type of intermittent time series. Another algorithm that is very common is Prophet. Prophet is basically the Facebook tunable forecasting model, and it's basically based on a popular Bayesian model, and it uses the Prophet class of the Python Prophet package. Is useful for data set that has extended time periods. So in example, when we have data sets that go through for months or for years, and when we have a strong seasonality, we can have multiple of those. When we have irregular events, nonlinear growth trends, and so on. And finally, my favorite, the Deep Autoregressive Plus, or DeepAR Plus. This is an algorithm that is a supervised learning algorithm for one-dimensional forecasting based on recurrent neural networks, so based on RNNs with deep learning. And the good thing is that it can train a single model across a set of time series. So you can have multiple time series at the same time, and it basically allows you to get to a target time series variable to get an accurate forecast, and it automatically detects the differences between the relationship between those data sets for you. So it normally outperforms ARIMA, ETS, and the traditional methods when we have hundreds of features in the time series and so on. Is if you're familiar with Amazon SageMaker DPAR algorithm, that's basically the same base but improved. That's why the plus is being added there, basically because it has three new features. The one of them is the learning rate scheduling, which helps you reduce loss and error in general in your models. The model averaging, which increase the robustness in general that you get with your forecasting. And the other one is the weighted sampling. So it allows you to ensure convergence no matter the size of your data set. So even when you have huge data sets, it helps you stay in convergence always in your model. So it is highly recommended as well. You can have all the documentation there in that URL that I'm showing. And the good thing about DeepAR Plus is that it supports automatic hyperparameter optimization, or HPO. So you can actually get Amazon forecast, calculate the best set of hyperparameters for you for getting the highest accuracy in your forecast. And we will see that as well in a minute. The good thing is that you can work with forecasts on different domains. And when you define your data set, you can specify if you're working with a retail data set, inventory planning, EC2 capacity, in example, or workforce or web traffic, when working with metrics in general, or setting a custom category. So let's say that you're working with any KPI that is not included in those use cases, you can set to custom. And it allows you to basically consider the features in a different way on each one of the cases. So that's very important because it's already taking into account some of the know-how that I mentioned before for helping you improving the accuracy of your forecast. Um, Amazon Forecast works with what we call probabilistic forecast. So that's basically by working with prediction intervals. What it means is basically that when you get a forecast in the service, you will get those variables that are called P10, P50, P19, and so on. And those are basically indications of the intervals that we have in our forecast, or what we say are the minimum and maximums that we see in the forecast that we are doing. And why are we working with that anyway? So the fact that we're working with prediction quantiles, which is the way that we call those P10, P50, and P90, and so on, is basically because if we make a distribution of the data, let's say that we see the frequency that we have in our data in general. I'm taking here a demo data set, and I see that in example in my data set, most of my values are in this interval that I have between 28 and 30. Um, Actually, if I calculate the media or average of that data set, I get that it gets to 40. But if I calculate the P50 of that data set, it actually tells me that it's 37. What it means is basically that it has a 50% probability that the values that I have in my data set are below this value of 37, and it has 90% in this case confidence level that I will have my values in the data set below 55. That is very useful when working with forecasts, because if you go with the media or the average in general, you are assuming that your data set is symmetric in general, or the distribution is actually symmetric, which means that we will be assuming that most of my data, in this case in my graph, will be here in the middle, and that's not really the case for most of the data sets. So in the real world, it's very important to work with forecasts that are based on those prediction quantiles for getting a good accuracy and a good indication of where I should be in my data. If you need more information about this, you can check the documentation on forecasts. It basically gives you more details on how those values are being used and why those are important and so on. All right, so it's time for going to the demo. So I will show you basically two demos here. The first one is going to be a console demo where we will basically go through an schema working with the AWS console directly, and then we will have a second demo that is based on a web application, simple web application that we have built, and we will see how to work with that application with the service in Amazon Forecast. So let's dive in. For the first one, we'll work with a setup like this. So basically, we will connect to the AWS console, and from there, we will do two things. The first thing, I will show you how to work with the Amazon Forecast directly from the console in the service. Then I will show you how to train those models from Amazon SageMaker Jupyter notebooks. That's optional. I mean, that's in case that you're familiar with the notebooks, that's a good way to work as well with the service or interact with the service, because you have all the power of SageMaker at the end also there. And we will always constantly be interacting with Amazon S3 for our data. So that's where we are going to store our data set and where we are going to export our forecast at the end if we want to keep it stored in a CSV file, an example. And then I will show you some bonus track here on how to visualize the information using Amazon Athena and a simple graph in Amazon QuickSight that you could eventually embed in a web page, an example. So let's go to this one before jumping any further. So the first thing that I would like to do is to go to my AWS console. So I will put it big here. If you are familiar with the AWS console, you know that you have here the list of services. One of the services that you will find if you type in here is Amazon Forecast. You can also look for it in the list of services that we have in general. If you go to Amazon Forecast, you will see something like this. You might have some service information here or not. And then you will have here the first layer, let's say, that is what we call the dataset groups. So each one of these can be seen as a different project in general in our service. So let's say that I want to work with this one. So if I go inside it, it shows me basically the flow where I have my data set. In my data set, I might have my target time series, I might have metadata, or I might have a related time series for it. In this case, I'm only using the target time series for this simple demo. So if you see what I have done here, and you can actually create this from scratch with the console by just saying upload dataset here. Let's say that I want to create and I want to start importing and so on. But in this case, what all I'm doing when I create this is defining a location for my data. So basically, what I'm telling it is that I have a S3 bucket in Amazon where I have my CSV file containing my time series in this case. So this data, if we analyze the data in general, see if I can switch windows here. What I'm basically trying to do is simply getting this data that you see here, where I have some timestamp, and then I have a value. In this case, is a demand for electricity that I'm working with my data set. And then I have an ID of my customers. In this case, I have client 12, client 10, client 111, and so on. So for this data set, if I go back to my console, I'm basically importing that information, and then I defining what's the schema that I have in my data. So it comes with a predefined schema that is based on those three variables or fields that I must have in my data, which is the timestamp, the target value, and the item ID. But I could also have order here that I can define here in my JSON structure directly. Once I have that defined, I can immediately import it, and it will tell me the number of entries that I have in my data and how many of these are unique and so on. And then I have my data set ready for working with it. The next step is creating a predictor. So here, a predictor is basically a trained model, and you can see different versions that I have here of my models. I can train a new one, and if I put a name here, in example, I put demo, I can indicate the horizon where I want it to predict in the future. So how far in the future I want to predict this data, assuming that my forecast is daily or hourly or by minute or per week, per month, per year, and so on, depending on how I define my data set before. I can choose the AutoML, as we said before, so it lets Amazon Forecast choose the right algorithm for my data set. Or I can go to manual and then choose one of my algorithms. Let's say that I choose the DPR Plus or any of the others. I can have options. In example, I want to say I want to consider the holidays in the United States into account for doing my forecast, and I can define the backtest window. So basically, how to split the data in training and evaluation, and the point where I want to split that data in general. And then I can have options that are advanced. In example, I can let it to perform auto hyperparameter optimization. So I could specify which hyperparameters I wanted to optimize automatically, and what are the ranges in general, the minimum and maximum that I wanted to consider when doing so. Or if not, then I can leave it as is, and then I could specify what are the features that I wanted to consider, any changes that I want to do in the configuration, like the learning rate and number of layers and so on. If I don't want to change the default, I just click on train predictor, and that will be it. So in a few minutes, it will be training one of those and so on. So let's look at one of the ones that I have here already trained. As you can see, this one was using DPR Plus. It was doing hyperparameter optimization. It shows me the horizon of 48 hours in this case that I have in my forecast, and it shows some of the quantile lost. So it basically tells me the interval of the accuracy that I have in my model. So in this case, between 0.15 for the 0.5, or for the 0.9 example is 0.05, and so on. So it's a decent model in terms of accuracy. And I also have the root mean square error if I prefer to work with accuracy based on those type of parameters and so on. I also have details here on the hyperparameter optimization that I did, what it chose at the end, and so on. If we go back, we can see other examples that are done, in this case with Prophet. This one was using AutoML, and it found that the Prophet was the best option, or the algorithm that gave the best accuracy in this case for this specific data set and so on. If we go to the forecast, once that we have our models already trained, so if we see it in the dashboard, we already passed to the second stage, and then we go to the third stage, which is actually getting the forecast from the models that I already have trained with my data. So when I want to generate the forecast, I basically create a new forecast here with a name. I specify what's the predictor or what's the trained model that I want to use for my forecast, and that's it. And it will generate something like this. So in example here, you can see my object. I could export it if I want. Once I have created this forecast, I could export it to a location in S3, which basically writes a CSV file with my forecast. It will be, if we go back to our data, it will generate something like this, where basically it will specify a timestamp, the ID of the client that I have chosen, and some quantiles. In this case, it would show me the P10, the P50, the P19, the P90, sorry, and so on. And the good thing is that if I want to do a lookup, in example, I want to choose one of my forecasts, in this case, this one, and I want to say, all right, I want to go, in example, from a given date. Let's say that I want to go from 2014, knowing my data set, 0 hours to 2015, like this. Let's say that for this item, I consider the client 10, and I try to get a forecast of that. Oh, it's telling me that it's not finding a client 10 in my data set, so I have to use something that is similar, let's say 110. It's not finding results for this specific one. Okay, I have one here. So in this case, I'm doing a forecast from the 31st of December of 2014 to the 2nd of January of 2015, and is doing it for the client, in this case 111, and it's giving me basically the historical data for the day before and then the forecast, because my data set is actually ending here. So here I can see the P10, P50, and P90 for my data, and this is my prediction interval in this specific case, and I can basically work with that. So that's a way to work with the service. Other way to work with the service is using Amazon SageMaker. So if I go here to SageMaker, example, you can see that you can go to notebook instances, in example, and create a new notebook here. I'm not going to go through this process of creating it because it's more on SageMaker itself, but it's documented already. When you open your Jupyter notebook, you will have something like this, and across the examples that you will have, if you see there is a repo already in AWS samples that is called Amazon Forecast Samples, and for that specific repo, you will have some notebooks that are already preloaded there and allow you to work with the service very easily. So one of them is called Getting Started with Forecast and AutoML. And it basically is a step-by-step notebook that explains you how to work with the service, how to set up Boat2Tree, which is this library that allows you to interact with other services in AWS, specifically with Amazon S3 for getting your data. It allows you to import that data. Basically, I'm using Python here in this notebook. So it allows you to work with pandas and all of the typical libraries in Python. And then I'm specifying where is my bucket and where's the information that I want to load, and how to work actually with the forecast service. So in this case, I'm saying I want to create a data set, so it created. I want to define the schema for my data set. I want to import my data. I want to create a predictor, in this case for the next 24 hours using ETS as the algorithm. Here it creates the model, basically trains the model. I get the metrics that I have in my accuracy, and I can actually create a forecast and get some predictions. So here you can see in a JSON how it's getting already the forecast that I have, and how I can show it here in my table. I can plot it and so on. So that's I can export it as well and so on. So that's a very simple way to work with the service. I have another example here based on the bike sharing Kaggle data. And it's pretty much the same. So how I do the pre-processing, I train my predictor, and then I create the forecast and I generate some forecast and plot it, and I export it to S3 and so on. So that's the other way of working with the service. Now, if we go to a service like Amazon Athena, in example, we can actually, as we have exported our forecast already, and we have written it in a CSV file in our S3 bucket, I could use that file basically for creating a meta table in Amazon Athena. So basically, if I do an SQL query like this in Athena, pointing to my exported data set and my original data set. So here I have export, and here I have my original data set. I could create some tables, and in those tables, I could basically work with the data directly, count the number of files or rows that I have. I don't know if I have the data loaded, but I could do some things like doing SQL queries directly over the data, as you can see here, and so on. I can do the same with the forecast, an example, and see how I see the data in the future already in a table in an SQL query. With all the quantiles that we were working before and so on. And we could even combine data. So in example, I could combine the data set and the forecast values for having a single data table, let's say, that includes my historical and my forecast. If we use that same approach with a service like QuickSight, in Amazon QuickSight, we could actually create some dashboard for visualizing that data. And I could do something like this, where I can basically make those graphs, line graphs, based on my Acme warehouse forecast, in this case for this demo that I'm creating. And as you can see, it's already painting here the January the 2nd, so it's already forecast data. And here it has the historical for December. In this case, I can even look back to my data set all the way up, or I can see only the forecast that I have here being painted and so on. You can also in QuickSight put that in a dashboard, and in that dashboard I can actually use it for embedding inside of a website. If you have an HTML website using JavaScript or any of that, you can actually embed this dashboard as an object in your website, and basically have an interactive graph here that already is updated with your forecast and so on. It's important to consider that the forecast can be automatically scheduled. So it keeps updating all the time where we have new data and so on. It's training new models, in example, every day, every week, or even every hour and so on. So that helps you having these kind of objects in your websites and so on, always up to date without manual intervention. All right. So let's go back to here. So we have gone through the whole path in both ways. And now let's go to the second demo. In this second demo, we will do something a little bit more interesting, which is basically I have a user that is a data scientist, and this data scientist has created already some predictors in Amazon Forecast. Let's say that he used the console or the Jupyter notebooks, or the SDK, the CLI, or anything. And it has interacted with the data that I have in Amazon S3. Exporting the forecast is optional, but let's say that it could have also exported the dashboard, the data, sorry. What we are going to do now is that I will use an application that I have for actually showing or interacting with business users with my forecast data. So this application is hosted in a service that is called AWS Cloud9, which is no more than a IDE that allows me to work totally serverless without having to have anything installed in my laptop or in my servers at home. And inside this Cloud9, I have launched an instance with basically Amazon Linux, and in that Amazon Linux, I will use a service called AWS Amplify. And Amplify simplifies the process of creating front ends and having authentication for my front ends and so on. So basically, it relies on services like Amazon Cognito for doing the authentication of my users in my applications. It allows me to work with typical frameworks as well. So we can use Node.js, we can work with the React in general, and so on. So For my specific example, I will be working with a front end and a back end. I will be having a back end basically because I'm going to be using the CLI commands from JavaScript directly. If you are using the SDK or the APIs directly of the service of Amazon Forecast, then you don't actually need the backend. You will simply do something like this in your front end. So doing a script, source, and point to the SDK of Amazon, the latest version, and then you will basically directly use the APIs that you have for Amazon Forecast from your front end. But in this specific case, I'm going to be working with the backend, as I said, because I want to use the CLI and so on. So basically, my web application will interact with the data that I have in S3, basically for getting the historical data and for uploading any new data that I might have in my website, and it will get the forecast by using a REST API to Amazon Forecast. So it's as simple as doing a call to Amazon Forecast for getting the forecast back. So before we go into that, it's important to see how this actually works in the terminal. So normally, if you are working with a terminal and you have the AWS CLI installed, you will have something like this. Let's see if I can make it bigger. And here in the service, you already will have, if you have the CLI updated, you already have AWS forecast as a command. So if I do help here, it will allow me to create data sets, predictors, delete, describe, list, and so on. So I could do things like AWS forecast list predictors, in example. And it will basically give me the list of predictors that I have already created. I can also describe a given predictor. So let's say that I put AWS forecast describe predictor, and I put the ARN or the unique identifier of the predictor for all the resources that we have in AWS. It will basically give me information about that predictors, about that model. So basically, what's the horizon that it has? In example, where is the HPO configuration? What is the input data set, and so on. So it gives you all the information that you need to have. And you can also ask for some accuracy metrics. So in example, if I do this, where I'm basically telling it, get the accuracy metrics for this predictor, it will give me the quantile loss that I have for my model in this case, and the root mean square error, and so on. And another command that is very useful is using forecast query. So forecast query basically is a command that allows you to get forecast. So get data for a given forecast. So in example, if I do something like this, where I say forecast query forecast, and I give the name, and I give a specific ID. So, an example, client 10 in this specific case, it will basically return all the values. I will actually do it in output text for easily visualizing this. So it will basically give me the percentiles, the quantiles that I have. So P90, P50, P10, and the timestamp, and the values that I have for this given customer, and so on. So this simple call that I'm doing with the CLI is the same that our application should be doing, and that's what we will try to do. So going back to my application. So let me choose the proper window from here. So if I have my Cloud9 environment, so let's say that I have an environment like this. Basically, this application that I'm going to be using now is available in a Git repo that I have here. You might have a look if you want later. It's basically on my ID, and it's called Forecast. It's a demo app that has a front end and a back end module. And basically here, what I have is an environment that I have already cloned from the GitHub. And from the front end, I can do simply npm start for starting my front end. I can do the same for my back end. And then it will allow me to have an application that looks like this. And basically, as you can see here, it allows me to create these kind of things very easily with Amplify. Based on Cognito. So I can do an authentication here for my users very easily. And once I have register, I can get into the thing, and I can indicate, in example, I want to see the forecast from the 31st to the 2nd for this given client in this case, and it will basically graph in your front end the information. So here you can see in the console how I'm doing a prediction, and it returns all my percentiles, my quantiles here. So those are the values that are being graphed here. And then I have the historical data that is being collected also from the service, either from S3 or even from Amazon Forecast if it's available. And that's it. It's a simple API that I'm doing to my service and showing it in a front end in this case. So that's the way in which we typically would work or interact with the service. All right, so we have seen the whole process for this. And basically, what we are looking to do with our customers with Amazon Forecast is put the AI to work for your specific business. So we have some customers like CJ Logistics or Mercado Libre, and those customers have been in the preview of Amazon Forecast that has been running during the first part of 2019, and they have seen extremely good results with the service. So in example, in Mercado Libre, which, if you know, is a retail portal for selling and buying articles online. They have been able to predict the demand for over 50,000 different products using Amazon Forecast based on the deep learning algorithms. And that's basically has simplified for them the process because they take the algorithms right out of the box. And Forecast takes care of the heavy lifting of setting up all the process, and it allows them to experiment very easily with hundreds of models. So that's a quote from Fernando Crossetti, who is a head of analytics at Mercado Libre, based in Argentina. And as this one, we have many customers that have been doing the preview and now are participating in the service once launched. And how we can help with you further. After this webinar, you can interact with our AWS account teams for getting help from the Machine Learning Solutions Lab. It can help you to do brainstorming, custom modeling, training, etc. Basically, by working with the best experts that we have in-house for making sure that you get your projects good. And the other thing you can do is join the Machine Learning University. So we have some training available already in our portals for you to join in the training and certification portal in AWS. For getting started, go to the repo that I have showed before. It's in GitHub, AWS samples, Amazon Forecast samples. It has notebooks. It can help you to modify data, build a solution, view and export predictions, and so on. And of course, check out the documentation on this URL. What is Forecast? Is basically a set of information like this, where you can find all the information about the service. You can see here the PDF version of the developer guide and so on. You have information about how to set up the CLI, and here you have basically the links to the SDK, to the sample notebooks, and so on. So that's it. You have my contact information there, and please reach out to us if you have more comments or questions about the service. And thank you for joining us.